right now I'll be talking about 2-stroke and 4-stroke engines in a comparative way, but not like this against this. I'll be discussing some important features where I'll be comparing both of them. So let me start with 2-stroke engines. The power output is twice that of 4-stroke. Yes. In the 2 revolutions in 4-stroke engines, you get 1 power stroke. Over here in just 2 strokes, you get 1 power stroke. So yes, it is justified. In 2-stroke engines, we have higher pressures and higher temperatures. Yes, definitely. So higher thermal stresses will be developed. Right? Hi GME aspirants, Jai Hind, Jai Bharat, Jai Mata Di. If you want to prepare on your own, information is the key. Download Merchant Navy Start app right now and start preparing. Suppose you're looking at faster results ASAP. Why don't you come to SMBD Marine Academy offline coaching? Yes, amazing mock interviews, amazing atmosphere, amazing results. More than 150 selections in 1 year. Jai Hind, Jai Bharat, Jai Mata Di. Result is yours. Less effective and high speed as poor scavenging. Come on, here in 1 stroke only you are doing compression and scavenging, right? So you have very less time for scavenging, and that is why you can't run it at high speed. If you run it at high speed, scavenging time reduces further, improper combustion will take place. So you have to make sure that you have sufficient time, and that is why it is used for 2-stroke engines are used for slow speed engines normally. Fuel consumption in 2-stroke engines is more because their thermal efficiency is less. In 2-stroke engines, you require more space and headroom as compared to a 4-stroke engine. Torque produced is regular, so smaller flywheel. Well, you have understood this used for low speed because of scavenging is an issue. These higher pressure and higher temperatures, all these are linked. One of the biggest reasons is because improper scavenging is taking place. Heat dissipation के लिए you don't get time. 2 strokes in the फट से combustion is taking place, right? Heat dissipation होगा रहा है. That's why higher pressure and higher temperature. Copied, guys? Now this is important. Torque produces regular or smaller flywheel because this is a common question. कि people also ask me, sir, 2-stroke में बड़ा flywheel क्यों नहीं लगता, sir? Why a smaller flywheel is fitted in a 2-stroke engine and why a larger flywheel is fitted on a 4-stroke engine? So now let's see, understand first of all, कि what is a flywheel? See, flywheel is a large mass which is connected to the crankshaft, a very heavy mass. Why? When the engine starts rotating, crankshaft will try to rotate, but this heavy mass is there, it will not allow it to rotate. But still engine is running, crankshaft will rotate, and along with that flywheel will start rotating. Clear? Earlier it was not rotating, but now because of its high moment of inertia it was not rotating, but now it has started rotating. Fine. Now when engine wants to stop, engine stops, crankshaft wants to stop, but because flywheel was rotating, it will still try to rotate the crankshaft. What the hell? When I want you to run, you are not running. When I want you to stop, you are not stopping. Then what the hell am I using you for? Now this is where is important. See, so now let's discuss why when I talk about a 2-stroke engine and I say that the flywheel is of a smaller size as compared to a 4-stroke engine. See, this is a crankshaft. It is rotating like this. This is the center. So what happens is, now say I have got a 6 units engine. So when all the 6 units have fired once, the crankshaft has rotated 1 complete turn. That means each single unit is responsible for 60 degrees of the crankshaft rotation. Right? So what happens is, suppose 1 unit fires. Now this is not a firing sequence. Normally the firing sequence is different. It's not like 1, 2, 3, 4, 5, 6. It is calculated after seeing how much is the torsional vibration, how much is the longitudinal vibration. It can be say 1, 4, 3, 2, 5, 6. Okay? But just to make it simple, I have shown it like, say it is number 1. The power stroke happens. By the time the piston has reached 60 degrees, and now the power is starting to reduce. Suddenly number 2 fires, bum, again. By the time piston has again further reached 60 degrees, third unit fires, bum, over here. So basically, if I talk about your crankshaft power, it is going like this: fast, slightly slow, then again fast, then slightly slow, then again fast, then slightly slow, then again fast. Right? And in between, whenever it is becoming slow, flywheel has got a larger moment of inertia. It is supplying that lost energy because it wants to rotate and crankshaft is slowly stopping, so it gives that energy out there. So flywheel is reciprocating, and that is why we get a uniform rotation of the crankshaft, or else it would have been like this: tick, 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 झटके लगते हैं. But what flywheel does is, it is becoming slow, okay, I will give you the energy. Slow, I will give you the energy. Slow, I will give you the energy. And it keeps it smooth. Gone? Now let's talk about the 4-stroke engine over here. Now what happens in a 4-stroke engine? Every 2 revolutions, there is 1 power stroke. So that means to say, if I make crankshaft like this, and I rotate it not once but twice, that is for 720 degrees. So that is how I get 6 units firing. So what does that mean? If one fires over here, second will fire over here, third will fire over here, fourth will fire over here, fifth will fire over here, and sixth will fire over here. Now the difference has increased to 120 degrees. Now what happens is, now when one rotates, tick, 120 degrees is a very large angle. So the rotation tries to stop more. And then number 2 fires. So in this case, it would have been more bad. Tick, tick, tick. झटका ज़्यादा लगता है यार. Tick, more violent. So out here, we need more energy from the flywheel. So for the same power of 2-stroke and the same power of 4-stroke, we need a bigger sized flywheel over here. Copied, guys? And that is where the basic concept lies. So please try to remember it in my way. Tick, tick, tick. But you don't have to explain that way to the interviewer. Make your own notes, make them legitimate, and then answer in your own way. Copied? So I hope this is also clear. Now let's talk about 4-stroke has got a complicated design. It has got a rocker arm fitted, it has got fuel wall, exhaust wall with spring, everything fitted, fuel wall in the center. What the hell are you trying to do? Complicated design. 4-stroke has less lube oil consumption because out here same lube oil is being used for the cylinder liner as well as for bearing lubrication as well. Out here in 2-stroke, you have got different lubrication for the cylinder liner and different from the crankcase, right? Power to weight ratio for a 4-stroke is more. I hope you have understood, right? If not, mention in the comment section. I'll leave an answer for that as well. Copied? Thank you very much. Jai Mata Di.